Okay, today's the last bit of this other function stuff. So families of functions, which, as we should know by now, just means that as a graph or a function of a particular type, that there's some sort of unknown, and as you can see in this particular example, we're telling you that it's a parabola, giving you a couple of points, and then there's an unknown there, in this case C, which is the y-intercept, as we're told. So we need to find an equation for this function, and the way that it's indicated is that there's going to be, that C will be there, so that indicates there's a family, and each individual member would depend on whatever the C is. So let's have a look at how we would start. So first of all, we need to define our function. As soon as we know it's a quadratic, we've been told that. We know it's of the form ax squared plus bx plus c. So a couple of things that we do know, there's a couple of points. 1, 6 is one of them, so when x is 1, f is 1, the answer is 6. And putting x equals 1 into what we've defined as f of x, we get a plus b plus c. Alright. The other point that we've got is when x is 2, and we're told that the answer is 4, and we put in x is 2, so first one 4a plus 2b plus c. So normally, as we know, if we're going to solve simultaneously and get answers for those a, b's and c's, we would need 3 equations, but in this case we've only got 2. We still solve them simultaneously. You can do this on your calculator. Alright, and when you do that, you find that A is equal to C minus 8 over 2, and B is negative 3C plus 20 over 2. Alright, so our quadratic function then is fx equals C minus 8 over 2x squared plus negative 3c plus 20 over 2x plus c. Alright, so that's a family because we've got this c in there. Alright. We could also get some other things, and with that we don't have a whole bunch of information about. And they would be literal type equations, so let's have a look at an example of that. Solve for x, so our thing we've got to solve for x is log to the base e of cx minus a equaling 1. We need to rearrange to get x by itself. Alright, so we need to remove this log to the base e, so we need e to the power of on both sides. So just a reminder, the reason that we do that is that these two things effectively cancel each other out, the e and the log base e. So we now got cx minus a, and e to the power of 1 is just e. Add a to both sides and divide by c, and you get a plus e all over c. Alright, so that one. We could use some matrix equations or matrix. Alright, matrix transformation. So here it is. So we've got a transformation that we do to get our image. So on the right hand side, the ones with the dashes, or x dash s prime, there's our image. And so to get our image, we do all of these these things. So we've got a transformation matrix there, and then we've got another transformation here. All right, so just this one here is your translation bit, and this one here would be reflections, dilations, and so on. All right, so find x and y in terms of x prime and y prime. So part A, we're using the matrix equation, so I'm going to leave some steps out here. So if we work out that matrix equation, so multiplying that first one out and then adding the other one, you get that 5x plus 5 is equal to x dash, and ky plus 2 is equal to y dash. When we rearrange, okay, so the one on the left here, rearrange that, take 5 divided by, and then divide by 5. We get this. The one on the right there, you get the y by itself. You've got to take 2 and divide by k. So just going back, checking part A, find x and y in terms of x dash and y dash. There we go. Got that. Second one, find the image of the curve with equation y equals 1 on x. Okay. So this is our original, is y equals 1 on x. So we're going to replace our x and our y in our original with these things here, the equivalent, which includes our image. Alright, so replacing the y by y dash take 2 on k, and the x by x dash take 5 on 5. Dividing by a fraction here, turn upside down and multiply. So you get y dash minus 2 over k equals 5 over x dash take 5. Alright, bit of rearrangement to be doing. So if we times by k both sides, first of all, and then after that add 2, you end up with y dash equals 5k over x dash minus 5 plus 2. Alright, so our image then is the graph or the equation that relates to the graph 5k over x minus 5 plus 2. Alright, so that's part B. And when we head back and have a look, see it says find the value of k if the image passes through the origin. Right, so if the image passes through the origin, what that means is it goes through the point 0, 0. So let's substitute that in. So when y is 0, so is x. And then when we do a bit of rearranging here, take 2 from both sides, and so k will be equal to 2. Alright, and so that's it. None of this is all that new, relatively brand new. A lot of it we've done with other equations and other functions before, simpler ones than the ones we've just been doing. Alright, so that's it, 7E questions, and that's all we've got for our SAC